gotten a little too ambitious on the start time, hoping to start at civil darkness, but now I know that it's nautical darkness that we need before we can achieve focus. So welcome. If you're new to the channel, we're located on the outskirts of Louisville, Kentucky. My name's Doug, and what we do here is electronically assisted astronomy. Thanks for being a part of this live, or if you're watching it recorded, either way, we're glad to have you. Welcome. We'll get started right away. We use a RASA. Let's see if we can get our scope cam going here. Why are we not seeing that? Looks like our scope cam has dropped. So we'll see if we can't get that back a little bit later. Let me just take a second and see how we can do that. Let's see. I'm going to go to this little program called say stop mirroring. There we go. Let's see if we can reacquire this. We've been using a security camera for our scope cam, and it actually sends the scope to our phone. And then we use a silly little workaround to mirror the phone screen into the laptop screen. Using a program called Reflector, and that has dropped. You know, a while ago it actually said there was an unstable signal, and for whatever reason it seems to have dropped. So we'll worry about that later. For right now, though, we're looking at Hidden Treasures 79. This is NGC 6242. And just for sort of night sky orientation, here's the very southern pole that we're looking toward, southern part of the sky. And then you can see that we're aimed here just around maybe 12 degrees up from the horizon. And it's this little cluster, NGC 6242. And we're using for this particular quick acquisition a little book called Hidden Treasures by Stephen James O'Meara. And we just have a few of these we need to pick up now and then to finish off the Hidden Treasures list. This one is called the NGC 6242. It's one of those bright open clusters that if it had been anywhere else in the sky, it would have been a celestial showpiece. Unfortunately, it lies close to, but just far enough away from, one of the most dynamic sections of the Scorpius Milky Way, the Scorpius OB1 association. And because of that, it's unfortunately not in a great spot of the sky. And it's also very far south. So therefore, I think it didn't make the Messier list, it didn't make the Caldwell list, and as a result, it's sometimes, I think, overlooked. Stephen James O'Meara, he tells you where to find it, and then he says Herschel actually found it with an 18-inch reflector in South Africa. There was a red star in the center. Let's go back to the live view, and there's the red star right in the center. See if we can tune up our, it's pretty close to the horizon. But anyway, there's the red star he's talking about, I believe. It's very, almost orange, isn't it? Considerable compression of stars toward the center. Different people see that star colored differently. Some people call it bright orange red. Yeah. And O'Meara says it's glorious, especially at low power. It's hard to discern the extent of the cluster, whose arms radiate wildly in every direction. So we're looking at it at 100% zoom. Let's back off to more of a, full RASA view, like about a 1.5 degree wide view. And you can see what he means there. These arms kind of careen out from it. So it's hard to see what is the cluster and what's not. So I'm going to go here to this cluster, NGC 6242, and do a quick observation. True, the central star is very red, orange, beautiful patch of sky, just low on the horizon for northern observers. You guys who are in the south might see this a little bit better than we do.
Observation logged.
Anyway, that's a part of the hidden treasure list that we had not caught yet. I think that might be all of the loose. Let me sort this one more time just to make sure. All the loose objects that we can pick up right now from the Caldwell list. We have probably another, 15 left on the Caldwell list, and another 1, 2, 3, 4, 5, 6, 7 on the hidden treasures list. We finished the Secret Deep, and we finished the Messier, of course, finished the Caldwell, finished the Herschel 400, interestingly enough. But these have just kind of dogged us for a while, these Caldwell objects that we're still missing. So I thought we ought to pick that one up while we could. All right, I'll look here and see what we've got here from the side. We've got about a dozen people. If you haven't already told us where you're logging on from, we wish you'd do that here on the live stream. And thanks for being a part of this. Let's go now and switch gears away from the Hidden Treasures list and back to Cosmic Challenge. This is a book by Phil Harrington. And you know, we've been looking at this for quite a while, trying to get set. So let's go back and let's go ahead and save this list. We'll just keep coming back to that when we can. And now let's switch over to the Cosmic Challenges. So the first one that dogs us here is the ACO 1367, or the Leo cluster. So let's head over to that object, and I'm sorry we don't have the scope view up. What you can do is look in the lower right and see the SkyCam view. Looks like we have a few clouds on the lower bank there. Dwight, good to have you aboard from Dunedin, Florida. Tropical storm watch. Boy, be safe there, Dwight. I hope you have access to some kind of a basement or something. Let's see. So we're going to stop live stacking here, of course. And we're going to try to go to ACO 1367, the Leo cluster. If it's not covered in clouds, let's go over to our SkyCam. Oh my goodness, why are those clouds there? Let's look real quick at clear sky, clear outside. Ah, look here, we've got some clouds that have snuck in here and could be around till midnight. Rats. This was a completely clear sky earlier, even as recently as 4 hours ago, completely clear sky, rats. Let's go back and check it out here. Look at all that in the, looks like it's in the west, isn't it? Let's
Selected.
sync with stellarium here. Yeah, it's in the west. That's exactly where we're headed now. Let's try a different part of the sky. Suppose we were to jump to HCG 50. I wonder if that one would be HCG 50.
Selected.
That's a little bit higher in the sky. How about this?
Selected.
East. Let's try to find something away from those clouds.
Selected.
Here we go. Let's try this in the east. See if we can get away from that cloud bank. Wendy, good to have you aboard. How about that? Oh boy, sorry about the rain, Dean. Mostly rain and some wind. Okay, well, I hope you don't get too much wind. And Ken, you're in Orlando. Oh boy, you've got a hurricane threat. Wow. Okay, so be sure and stay safe, Ken. All right, so you can see on the screen here on Stellarium, which is a free, by the way, software you can install and be able to look on your computer at kind of the observatory experience, like planetarium, you might say. And it's absolutely free and a lot of fun to use. Stellarium. Papa Tech, good to have you aboard. Papa Tech, are you under this hurricane threat as well? Okay, let's go back to our sky cam. This is a little better patch of the night sky, so let's hope we can do better here. So this is going to be IC5164. Get things dialed in. IC5164. In the Cosmic Challenge, this is object 62. It had been a while since I've been able to do a live stream. I've been out of town some, and also it seems like we've been hit with a lot of bad weather here. So thanks for putting up with now. I wonder why we can't get the scope cam dialed in. Let's see. How could we do this? One thing we need to do is get rid of maybe that reflector software, or maybe we can just, yeah, let's get rid of that reflector software. So I'm gonna go to Task Manager for a second and kind of force that closed. Oh, it looks, oh, there it is. Okay, then let's reopen that. It's called Reflector 4. Okay, then let's go. Hmm, 5, 3, 2, 1. Okay, so now it's mirroring. There we go. Now I need to go back to the scope cam screen and reselect that. There we go. Okay, sorry for that. If for some reason that had dropped a while ago, I had seen the little warning on the phone that it said this is now an unstable connection. Boy, it seems like we're getting clouds here as well, aren't we? Let's go to the sky view. Maybe they're just going through in patches, aren't they? It's an interesting view. You can see the light on in my window here. This is the office that I'm using in this building, which is about 200 feet away from the actual observatory here, which is, like I say, it's about 200 feet out in the side area. By the way, we've got this RASA scope. You might already be aware if you're on the channel some. It's an 11-inch Roe Ackerman Schmidt astrograph, or RASA. And that's a live view over there in a roll-off roof Pier-Tech Tele-Station 2 observatory. So let's go back now and see if we can't. Let's restart this live stack. We're using SharpCap to gather our images. And Larry, it sounds like you've got a clear night, but the seeing is bad. Yeah, we've got clouds here as well. Ugly. A lot of, I don't think we're going to be able to see IC5146 and Bernard 168 here. It's an emission nebula, so it's an H2 region. And with this much mist and clouds, I'm not sure. I don't think we're going to be able to see this. Let's see. What will it take to dial those clouds out? Maybe that much. Now the question is, can we go over to Stellarium.
Selected.
They don't have any artwork or anything on this. That's odd, isn't it? IC5164. It's a celestial odd couple. So you've got the emission nebula, and then you've got some dark nebula in front of it. So you've got dark nebula in front of the emission nebula. Oh, it's known by its nickname, the Cocoon Nebula. taxing patch of glowing gas. And then Bernard 168 is a thin, sinuous lane of darkness. Let's go back to the live view. So it's questionable whether we're going to be able to see through this mist well enough. Let's start the live stack over again. The good news is, if we wait, it looks like Clear Sky is saying the clouds are going to dissipate some. Let's go back to clear out. I keep saying Clear Sky. It's clear outside. Let's refresh this. Okay, so that's the latest. So what is it? 10:18. Wow, it could be as long as midnight before it's completely clear, though. That's not good. Nice little airplane flying by here. We know it's an airplane because look, it was pulsing. This actually is looking a little bit better, even though it might not look better there. There's a little bit less. What altitude are we here? Let's go back to Stellarium and just see the altitude. Let's see, 31 degrees. So that must have been a mean patch of mist there, right? So we can take out all that mist, but it's going to take out the H2 region as well with it. Let's see if we've got any other more appropriate targets here, since that is still being occluded, or whatever word you want to use. How about we go to a globular cluster? Let's do that. Here is NGC 6453. Let's do that. Tiffany, good to have you aboard from San Jose. And Ray came on at the same time from Arizona. Good to have you guys aboard. We've got a lot of clouds tonight, sad to say. You can see them kind of scooting by there. Oh, we're right back into the cloud bank here, aren't we? I don't know if we're going to be able to see this globular through those clouds or not. Let's try it. So let's go back to the live view, and what we're going to try to see here is NGC 6453. My goodness. What in the world here? Is that just because of the cloud banks picking up the night, the city lights, or what? Yes, that's exactly what that is. That's just a beautiful picture of a cloud bank. Let's see if we can look at this globular cluster through the clouds. I think that would be it right there, wouldn't it? Let's do this. Let's go to our deep sky image annotation. Alt-D. Right there it is. 6453. Now if I go Alt-D, does it turn it back off? Alt-D. Yeah, it does. Okay, so that's a very poor rendition of NGC 6453 through a cloud bank. This is object number 98. The open cluster team of M6 and M7 floating just north of Scorpion Stinger creates one of the prettiest binocular sights in the summer sky. Even the smallest pocket binocular will show that the brightest stars in M6 form a rectangular pattern that inventive eyes can imagine as the outline of a butterfly. M7 is even larger and brighter, and it bursts as an exceptionally striking assortment of stars covering an area larger than the full moon. Although conventional wisdom says that M7 is far too large to enjoy through most telescopes, John Herschel is credited with discovering the little gem NGC 6453 on June 8, 1837. So let's back out to full auto and appreciate some more of these clouds. Look at these open clusters here that are, let's go back over to Stellarium real quick.
Selected.
And let's back off. Whoops. I do that sometimes. So we're looking up in the, above the southern part of the sky. And there is Ptolemy's cluster here. That must be the butterfly cluster. And then M7 must be over here, but this little NGC 6453 is in the middle of a very, look how many stars and how much Milky Way dust there is there. Look how it's a very rich part of the night sky. Back to the live view. So there's that cluster. Yeah, there's so much cloud. There's so many clouds now that we're no longer stacking. Okay, we're going to go ahead and do a quick observation of this. Hidden by M6 and M7, viewed on a cloudy night. Couldn't appreciate the full beauty of this globular. But nevertheless, we observed it.
Observation logged.
Stu, good to have you aboard from down in Tauranga, New Zealand. Corin, good to have you there as well. All right, let's go back to our sky view now. Take a look at that cloud bank. So let's get up and to the left a little. So in other words, let's go over here to the eastern sky if we can. See what we can find. How about this? Where is this one? That's still south, but a little bit farther east. UKS-1. Boy, that must be an exotic globular, huh? Let's go there. Now we've got our, do we still have our, there we go. Having trouble with our scope cam tonight, aren't we? Anyway, there it is, back again. Let's go to the live view. And again, isn't this a strange name for a globular? UKS-1. Looks like a slightly better view of the night sky, huh? Dwight, good to have had you on board. Sorry it's been so cloudy here. Corin, it's okay. We were forecasted as a really clear night, but as you can see in the scope cam view, it is not. And there's the sky cam view showing how literally half the sky is the word occluded by those clouds. Pretty mean looking there. Okay, we're back live here again. Let's still looking through mist. Okay, this is supposed to be a globular also. So let's do the same thing. Let's go to our tools and plate solve only. And then deep sky image annotation. Also, this isn't even in sharp cap. So what we'll do is we'll add it. And we do that by going up here to Pete's little control panel, EACP, and we'll say Sharp Cap DSA.
Completed.
Then we'll come back to Sharp Cap, add Deep Sky Image Annotation, and then what we do is we take this little panel here and say Paste Custom Object Info, and then click on it, and sure enough, there it is. So thank you, Pete, for allowing us to do all that. Okay, now let's, man, this is such a rich star field, isn't it? Let's go over to Sharp Cap real quick.
Selected.
Stellarium, sorry. Over to Stellarium real quick. Oops, there I did that again. I get mixed up. This is right in the heart of the Milky Way, so it's a very cloudy and a rich star field anyway. I'm just not seeing a globular there in Stellarium. What do you make of that? Let's go look this up in our Cosmic Challenge. It's supposed to be object 168. It does say it requires a 15-inch scope. 168. And we only have an 11-inch scope, remember. Thanks to their intense cores, most globular clusters punch through light pollution better than some other types of deep sky objects. There are exceptions to every rule, however, and here we find a beauty. Can we see the invisible? UKS-1, more formally known as UKS 1751-241, certainly deserves a foreboding description. After all, how could it escape detection on the National Geographic Society Palomar Observatory Sky Survey charts, as well as on images obtained as part of the Sloan Digital Sky Survey? Their limited magnitude approaches 22nd magnitude on average. Well, somehow it did. UKS-1 first came to the astronomical world's attention in 1980. So this was just discovered 40 years ago when Matthew Malakan and some others published a research paper entitled Infrared Studies of Globular Clusters. And their opening paragraphs, the authors note that UKS-1 was discovered by the group. They used infrared plates using a 1.2 meter, so what would that be, about 5 foot wide Schmidt telescope, a 5-foot aperture, and it appears as a small round hazy patch, no brighter than 16th magnitude on infrared plates. It's a victim of circumstance. Plot its coordinates on any sky chart and it quickly becomes apparent why. It is in the Sagittarius sky cloud, a scant 5 degrees from the center of the Milky Way. There's a lot of cosmic dust here. I would say so. How could we hope to see it visually? So she thought it would be, here's this lady, Barbara Wilson, thought it would be visible in 20-inch. That wasn't the case. She tried for 4 years. She referenced the CCD image field taken with the 18-inch at Houston Museum of Natural Sciences George Observatory. Then they used a 36-inch reflector just east of a pair of unequal brightness stars, 14th, 15th magnitude. Say it again, let's use her chart. Oh, I see here. So it should be exactly there where Pete has it plotted. This is at 358%. So to put things in perspective, there is 100%. So let's remember those two stars right in the center and take deep sky magentitation back off. So you think it's right there? And this was not in stellarium, is that right? It is not in stellarium. Bummer. So right there, huh? Okay. If we take out through these clouds we're looking at tonight, look at that. We have to just take out some more of the mist, and then we get it right here. Let's see if that's where it's supposed to be. Oh, no, down here, sorry. Boy, there's so much gray in there with the cloud, isn't there? Can we pull more of this grain out? Boy. Let's go look at our sky cam again. Just depends on which patch is in our way, doesn't it? Now that looks like a better patch of sky coming at us. So let's clear the live stack and start again. See what you guys are saying here. Corin, we were having the same weather in London. Ray, the whole year has been with some clouds here in Arizona. Same here, Ray. Tiffany, looking soupy for sure. 2 clear nights last week. Get some data on the Iris Nebula. Tiffany says, a lot going on in that field. You're right, Tiff. Larry, about 100 miles south of Doug, clear but very humid, soupy. Ray's got M27. Redangled love $. Good to have you aboard. And Ray says forecast for clear skies tomorrow night. Well, it was supposed to be clear tonight, Ray. It's a cloud dodgeball. Yep, that's exactly what it is, Ray. Okay, this is ugly. Man. It's clear again. Hope that we can play some dodgeball here. You know, I'm really liking the suite of the 3 programs with SharpCap as the image gathering software, Stellarium as the planetarium software, Astro Planner for target tracking, you know, and observation tracking. Really liking that suite. Another thing I'd like to recommend was an intro to astronomy class. Let me see if I'm going to put that in the chat. Although, if I remember right, the chat is not clickable, is it? I think that ends up not being clickable. In other words, so what I'll do is I'll put that in this. Oh, it is clickable, yeah. I'll put that in the description as well. It's a really good observational astronomy class. I would say any of us could and should watch like the first hour of it. And then the deeper you get, the more and more technical it gets. And so we might not. There are some among us who won't stick with it past the first hour, but I think the first hour is worth doing for anybody to get the basics of observational astronomy. You see, observational astronomy is so different than things like, like cosmology and the sciences of trying to predict how the universe was birthed and all that. All that theoretical astrophysics stuff. That's so different than what we do here on the channel. What we do is just pure observational astronomy, only with a telescope. But this channel that I'm telling you about is really good for. Well, this is just not a good patch of the night sky after all, is it? So I don't think we'll enter that as an observation. There are a couple of dark nebulas. There are some galaxies, but again, it just depends on. I'm looking at our target list to see what else we've got here. Here's another globular. Let's see where that is.
Selected.
That's toward the east. That might be better. So let's just go to that. So let's see. Let's go here and let's stop this live stacking business because we're not making much progress there, are we? Let's go to this part of the night sky and see what it looks like. Look at those clouds. This is at about 17 degrees altitude. Pete's the rock star. You're right, Tiffany. Very kind. Okay, so you can see once again it's cloud dodgeball again. The good news is this is supposed to disappear. It's supposed to dissipate. So if we can get to a nice part of the night sky, this is PAL 13. Anyway, this Jason guy, he has a really good intro to observational astronomy channel. I think you'll really like it. At least the first hour of it. Dave, I hope you have better dark sky than what we have here. Okay, this might be a little more promising. I believe it is more promising. We caught this away from clouds. Palomar 13, though, is still not visible, is it? It is not in the sharp cap, so using Pete's EAACP panel, we'll say sharp cap DSA,
completed.
and then we'll go here and paste that custom object in, and there it is. Thank you, Pete. Man. It's supposed to be right there. That's 110% zoom. Let's look at Stellarium.
Selected.
It's not in Stellarium either. These are definitely exotic objects. So back here, let's just, I wonder, there's a blotch down there. Could it be? Oh, we must have hit clouds again because it's rejected the last 6 frames. So we had another patch of clouds come in. Bummer. Yeah, look, just came right across our view, didn't it? The good news is, look, once that's out of the way, it's still going to be a bad seeing. Oh, Dave's got clear skies in Colorado. Let's read about this 145. Saturn would be a good target. 145. Pegasus is best known to deep sky observers as a breeding ground for faint galaxies, with more than 100 faint NGC galaxies littering this winged steed. Floating seemingly out of place among these systems is the globular cluster M15, one of the season's finest, but there is a second globular within Pegasus. Lying within the grasp of your 10-inch telescope, this little-known target is Palomar 13, one of those nasty globulars discovered by Abel and company while surveying the Palomar Observatory Sky Survey a half-century ago. He nicknamed his find the Pegasus Globular Cluster, apparently forgetting all about M15. He omitted this ill-conceived nickname when they did their final list of Palomar clusters. Its 14th magnitude Oh, 6 rejected frames in live stacking because of clouds. Sadness. Boy, gang, I'm sorry. Wonder if, I tell you what we might do is let you off the hook and say, let's try again tomorrow night. If you feel like that it's, you got to choose between the two nights, let's come back tomorrow night. Let's go check the clear outside. Look at tomorrow night. Now tomorrow night is also clouding up. It's supposed to be completely clear by midnight here. So it's another hour. So I'm going to stay. I think I'm going to stay, but you guys are welcome to go ahead and hit the sack. As it turns out, tomorrow night's not going to be a good night either, but Monday night, according to the forecast right now anyway, we'll be back Monday night and try this again. Boy, look at these other nights coming up. Just so socked in. Monday night's a ticket, 2% moon. We will start around nautical dark is what we need. No, yeah, nautical dark. So we'll start around 10 p.m., 9:50. So we'll plan on starting at 10 p.m. Monday night Eastern time. But I'm going to stick around because once we get to midnight, which is just an hour away for us here, these clouds are supposed to dissipate. 4 frames rejected. This is just sad, isn't it? I have these things called bear bites. It's pretty bad. We've dropped down to the problem of me showing you my snack food. These bear bites are made by the people who make Kodiak pancake mix. And they're supposed to be completely wheat flour. So there's very little, you know, supposedly, I don't know, I'll have to do some research on them. It's supposedly a little sugar. Either way, they make neat little animal crackers without all the sugar. Bear bites. Okay. We have 3 frames. This is awesome. Four frames. It's 14th magnitude. It's one of the smallest, faintest globular clusters known. It takes extra effort to be seen. With a 10-inch, you can typically just see it as a small, hazy spot. No evidence of a central concentration. Instead, only a dim, featureless blur. How about that? We have 6 frames, 120 seconds here. Over the course of its 1.1 billion year orbit, it can lie far from the galactic core as it does now, 284,000 light years away. Huh. 70 million years ago, it was in the heart of the Milky Way. So there's one paper written about it called A Cluster's Last Stand, The Death of Palomar 13. I think it's in the final throes of destruction. All right, let's find this baby. Once again, it should be, we have 10 frames. It should be right there. (273% digital zoom. Oh, we are not seeing it. Let's bring up some more of the background. Ah, that's helping us, isn't it? I wonder if that did it. Think that's it? We have 12 frames. Let's look for the deep sky image annotation again. It's very possible that it's that. Yes, it would make a triangle. It would make a triangle with this star, so that is probably it. Let's get rid of just a slight bit of that grain by backing off the mids. Right there. A small hazy spot. Huh. Boy, I'm going to hold the shift key down, which lets you fine-tune that bar a little more slowly. So I'm messing with the black level, just seeing if we have 19 frames, but it still could be misty. Let's look at the sky cam again. Yeah, so see if you just get a little bit of that mist in there. Oh, look, the parking lot lights have come on. That's introducing some extra sky glow, isn't it? You know what? I'm going to go shut those off. Let's let this cook. And if you don't mind, I'm going to go shut off those parking lot lights. They weren't on when I started. Now my mic, maybe my mic will drop, but I have to go down to the lower level and switch those off. I don't know if you can still hear me or not. I'm down in the lower level of our building, head into the data center. In the data center, first I can override this. Lights. I started so early tonight because I started earlier tonight. They weren't on when I began the live stream. They've come on since the live stream started. Okay. Now I wonder. Let's clear this and start over again. Maybe we'll get rid of those strange blue lights. We're zoomed in at 180% here. 180% of our... Wendy said that you guys could hear doors opening and closing. Oh, this is so much darker background now, isn't it? All that blue chatter we were getting in the image was due to the silly parking lot lights, and this particular target was over there low in the sky. Now let's look at the, oh yeah, clouds are dissipating. Woohoo! Oh yeah. Now we're able to turn that up some. So it could be this blotch here. Let's do a solve only again. And then one more time. Oh, it's a little over to the left. Anybody seeing it? Because I'm still not. Unless it's that. But according to the Deep Sky Image Annotation, yeah, it does look a lot better now, doesn't it, Tiffany? We've also got this. It might be this little thing here. I mean, with this small of a target, being off that much is a very real possibility, isn't it? It's magnitude 15. Look at that. We are way past the limits of our scope, 300%, but what if that's it right there? Or what if it's in the middle here and we just haven't? We're at 4 minutes. Makes me want to look at a higher res star chart. Let's see. Let's back off and look. Here's the star chart they give you to find it. So there's evidently a kite-shaped asterism. And then it's kind of off to the right of the bottom end of the kite tail. Corin says, I think we need a bigger telescope. Oh, you're right. Okay, let's back off so we can see. Here's the kite-shaped asterism. For sure. Because see, you've got this kite and then this little star here in the middle. Take a look at this. I'll try to picture it so that you'll recognize it when you see it. So notice how there's the top of the kite, and then see this little star here that's kind of a third of the way down the left side of this kite angle. And then the actual Palomar 13 globular cluster is supposed to be off like a kite tail would be right off the end of the kite, a little bit to the right at a 45-degree angle. So let's go back to the screen. So here is the kite. So you see the kite. And then here is that little dot about a third of the way down the left side. Then Palomar 13 is supposed to be off at a 45-degree angle. Now, we do see this star in the diagram, but Palomar 13, according to this diagram, should make an isosceles triangle with that star. So it should be right here. Now let's see carefully if we, yep, that's exactly where it should be. So the deep sky image annotation is dead on. All right, so let's turn up the confetti a little. Ah, now look at that. There's a new object. That's it. Right here is a star that's actually it is a globular cluster. How about that? There's so much confetti. Look at that. It's probably the best view of it right there. When you hold the shift key down, I'm going to back off just one. When you hold the shift key down, you know, it lets you do fine tuning on these adjustment bars on the large histogram, the live stacking histogram. I'm just backing off one step at a time. Now watch. So that star is not on this chart. And the globular cluster is supposed to be right here. So maybe that star is part of it, or maybe that's part of the globular cluster. You can see some stars forming here now, can't you? Yeah, right. Let's do the mid-levels. And let's zoom in a little more, even though it's kind of an artificial, you know, it's really wild that this globular cluster is making literally 1 pixel at a time on our ZWO ASI2600MC Pro. So right there, let's go right here. Boy, it takes a lot of patience. We have 30 frames here, and each frame is about 20 seconds. So 10 minutes and 21 seconds. And we're just also at the limits of size and seeing this object. Let's see what size it is. 1.8 arc minutes. So about 1/30th of a degree. And we're seeing individual stars, presumably, in that globular cluster. There you go. See these individual stars. unless that is just it. Because that star is not on this chart. Tell you what I'm going to do. I'm going to snap a photo of this with the kite asterism. What about there? Something like that. No wonder this escaped detection for so long, right, gang? Who would be combing the night sky enough to see this? I'm going to call this PL13. And we'll add that it's 12 minutes, 38 subs. This globular is so tiny, 1.8 arc minutes, and so faint, 15 degrees, and seeing was not that great tonight. But we had a great time tracking it down. We'd still love to confirm which set of lit up pixels it might be. But we believe we've snagged it. So exotic.
Observation logged.
Okay. You know, if you just look at that view, this is a star. Look how it's pixelated to show we're at 410%, but look how this definitely has a different timbre, doesn't it? Different color. And then when you add all that confetti, and the confetti is mostly blue and red, but here there's a preponderance of yellowish tiny dots. Let's do one more thing, just because we're Palomar 13 wiki. How do you know you're looking at an exotic object? It's when there's no Wikipedia entry about it. 13. Oh, it says 0.7 arc minutes. Let's correct that in our data here. 0.7 arc minutes. That's a little more, believable, isn't it? Still 14 magnitude. Some of them you can resolve individual stars, some look hazy. Let's check our, this is 2306, 44, yeah, 44.4, 1246.19, spot on the coordinates. Right here. Take a look at that. That's it, right here. Boy, that is so tiny. Well, the good news is, I'm guessing that probably nobody on this live stream has ever observed Palomar 13 live before. Have you guys? Tiffany cleaned her glasses to be able to see it. 15 degrees is very low. That's true too. Sort the list again so we get a refreshing on that. Altitude. Eat another bear bite. $24 degrees. I think this is it. And I think when we put the, I think that's just an approximate location. But I think this is it. Look how that's got a couple of side stars. Let's go over one more time. Palomar 13, globular cluster. Aha! Oh, that's not very helpful, is it? This is from the Palomar 13 in Galaxy NGC 7479. Uncropped full resolution 19 by. Okay, so let's find our, wait. Is it right there? I've lost the kite. How about you guys? Oh, his camera's turned a different angle, apparently. Where is this NGC 7479? NGC 7479. NGC 7479 is here. So that aligns with the top of the kite. Let's go back to this. So let's look at the uncropped. So here's 7479. That aligns with the top of the kite. So it must be right there in the center. Man, I don't see the kite in that picture. Unless that's not it, but anyway, this is what the globular cluster looks like. Okay, so now we're back to our live view again. Right there. It's a little, yeah. Boy, that was tricky to bring out. There's a little basket of stars that reminds you of the little basket that's in the Orion. What's it called? Those four stars where the star forming region is in Orion 42. Look at that. Very tough to bring out. I could have never hoped to discover that. Look at stars here. There you go. So it took 26 minutes of EAA and a lot of patience. Look at it up here. So there's the extent of it. Let's put the deep sky image annotation on one more time. Yeah. Very faint. Okay, you guys see it? Corin says, you found it, Doug. Trapezium, that's it, Ray. That's what I was trying to think of. Wow. This took patience, guys. But I tell you, this is, I don't know why, but I really enjoy this kind of astronomy. Trying to find these exotic targets like that. Tiffany just lost her internet signal. Tiffany, I hope you're back. This is what we're seeing here. This collection of these little glimmers of stars. It's got to be the most faint globular cluster ever that we've seen in history. All right, let's call it. We're gonna snap one more picture now. Boy, unless you're zoomed in. This is at the limit of our scope's ability, isn't it? This is Palomar 13. And we're now at 85 subs for a total of 28 minutes. I dare say you will not find another channel on the entire world of YouTube that will spend 29 minutes to be able to find that. Nobody else does that. That's just crazy. Anyway, thanks for your patience, gang. Now, I bet you anything, a lot of our clouds have dissipated. Let's go check it out. Oh yeah, that's beautiful, isn't it? Now, is that current? Did those parking lot lights come back on? They are absolute rascals. Look at that. I turned them off, but the timer has slid them back on somehow. Okay, grab yourself a coffee. I'm going to go try one more time to defeat these parking lot lights because they will definitely cause blue light in our image. Rascal parking lot lights. Why do people even need parking lot lights? Can't they just... Parks the parking lot at night should have to just take a flashlight. It should be against the law. Parking lot lights should be against the law. How did this come back on? Okay. Parking lot lights should be against the law. There should be regulations about these things. you should. You don't need parking lot lights. Just if you're gonna drive your car somewhere at night, just take a flashlight. Why should we use parking lot lights? It's a dumb idea. Just take a flashlight when you're parking at night, and we'll be done with these things. Okay, where were we? Oh, that's so much more beautiful, isn't it? All right. Now let's see if we can go back to the beginning here. Mike says, I admire your perseverance. Well, you guys as well. You guys stuck with me as well. Ray says, we're all pulling for you, Doug. Ah, Larry says a BB gun could handle it. We're all astro geeks. Okay. All right, so let's go to Einstein's cross. What about that? It's a quasar. It's at 26 degrees. Let's go there. Einstein's cross. Einstein's cross. That's a long name. HB, like Harvey Bravo, Hotel Bravo, 932237 plus 030. Where does that name even come from? What is Einstein's cross? A quasar. It's object number 176. Einstein's cross. A quasar. One of the predictions of Albert Einstein's 1916 general theory of relativity was that the light from a bright, far-off source of energy would be warped or bent around the massive object lying between the source and an observer. In the process, the time it takes the light to reach an observer would be altered, causing the background object to appear magnified and distorted. Wendy said, we saw the second you turned the lights off. That's good. Dean, the township has no light ordinance. Neighbors love lighting it up. It's sick, really. Wendy says, lots of muttering. That was what Einstein's theory said, but how could it be put to the test? The most massive nearby objects known at the time, such as the sun, were also very bright. Anything that happens to lie beyond would be so faint. So skipping a lot of text. This warping effect is known as gravitational lensing. Photographs taken with Hubble Space Telescope show the effect well. The most perfect gravitational lens is Einstein's cross, formed by the galaxy PGC 69457 and the quasar QSO 2237 plus 0305 in Pegasus. Current estimates place this small, otherwise inspectacular galaxy at 400 million light years away. The quasar looks far behind, an incredible distance, 8 billion light years. That's like 60,000 gigawatts. 8 billion light years. Were it not for gravitational lensing, the quasar would remain hidden by the galaxy, but as it is, Hukra's lens, its PGC 69457 is informally known as Hukra's lens, fractures the ancient light from the quasar into 4 separate paths that slide around the galaxy just as water flows around a rock. The end result is not 1 but 4 ghostly images of the quasar in a practically perfect diamond pattern. Einstein's cross lies to the south of Flying Horse's head and neck and due west of Circular Pisces, so he tells you how to find it. It's rated at 15th magnitude. He's seen it with difficulty in his 18-inch reflector. We're going to try this with an 11-inch scope. Oh, but he can't see the quasar. He's never been able to see the separate 4 quasar images. Instead, all 5 remain blurred into a single object. It has an angular size of 1.6 arc seconds. Okay, so if you guys need to hit the sack, we would totally understand it, but let's try it. So, first let's try to find the galaxy. PGC 69457. So let's go see what Stellarium has.
Selected.
Where's Stellarium? There it is. Oh my goodness, it has nothing. It's completely black. That's not a good sign. Now let's do the so we're going to have to do shortcut
DSA
DSA.
completed.
Thank you, Pete. So there's where it's supposed to appear. Wow, so there's nothing there. Shouldn't we have had PGC 69457? Why is that so bright? Boy, it takes a while sometimes to tune these things up, doesn't it? I love how dark it is tonight now. We don't have perfect seeing, but okay, so first we're trying to see this galaxy. Man, we can't even see the galaxy yet. This is bad. My goodness. Are we going to need a better star atlas to see this? I need a bear bite. Shouldn't we be able to see the galaxy? Huh. We need a better star chart for this. Let's go out to the web. And let's search for PGC 69457. fascinating. We can just see it in huh. Okay, so here's a line of stars. 1, 2, 3, 4 in a straight line. And there's a little mountain triangle at the end of them. 1, 2, 3, and that star is a double star. Then below it here are 2 stars, and it sort of curves up. This whole thing looks like a seal. And there's the head of the seal, right about where the front legs would be. Okay, so let's go back to this. This is our live view. Okay, now here are 4 stars. 4 stars. But that doesn't mean it's the same 4 stars. Let's turn that off for a second and do one more solve only, just to make sure we're looking at the right part of the screen. Yeah, right there is where it's supposed to be. So where are the 4 stars in a line? Could maybe stand to focus again before we go on this hunt, do you think? Doesn't look too bad at full. Yeah, let's just focus again. Let's take a minute to do that. If we're going to do this, let's do it right. This is Einstein's cross, after all. Camera, Nina. Oh my goodness, Corin. It's 4:42 a.m. Do you have to, like, sleep some tonight? You're a dedicated exotic object hunter. Okay, so we're opening up Nina, going to the automatic focusing routine. So the secret is bear bites. You have to have bear bites. Oh, this is a different configuration. This is a bear claw. See the little toes? Little 5 little foot pads. Gotta have bear bites. Kodiak bear bites. If you're new to the channel, we really like Nina for autofocus, for a RASA. Because remember, the range of focus the range of acceptable focus for a RASA 11 is thinner than the width of your grandmother's human hair. And I say grandmother because you cannot compare it to a thick strand of hair. It has to be a thin strand of hair. And the acceptable range of focus is thinner than that. So I'm telling you, if you were trying to use one of those masks, you know, that's supposed to make the diamond, and you're trying to do that with your hands, you're a better man or woman than I am, because I can never achieve human hair, grandmother's human hair level focus on a RASA 11 manually. So, to me, you have to let AI do it. You have to let the computer do it. And what this does, each one of these dots that you see on this graph, it is a couple of attempts of shooting a shot of the field of view and then moving the focuser 30 stops, 30 positions. And those positions are just so tiny. Then it shoots another couple of pictures, averages them, moves it, keeps moving in the same direction until you see a bottoming out of that hyperbola, that parabola. And what that bottoming out represents is the thickness of the stars, the luminosity, the half flux radius luminosity of the star. And then it keeps moving through that low spot until on the other side you see the stars are thickening again. And once it proves to itself that, yes, I've moved past the low point of the parabola, in other words, the stars were as tiny as I can make them, then it goes back and sets the focuser for exactly this point. So it makes for a really precise focus, and honestly, look how short of amount of time that took. It's just that, to my knowledge, Robin has not added that yet in SharpCap, so we have to use a sister program called Nina, which is really designed for astrophotography, I think. We have to use Nina to, oh my goodness, yes, look how much sharper those are. Now let's turn our live stacking back on. So now we're going to say prep for imaging only. Excuse me. So what that does is tweaks everything for imaging and then puts us back in the... Tiffany says she's had Kodiak pancakes. Good stuff. I love those, Tiffany. Okay, we're back live again with Einstein's cross. Let's set our live stacking histogram up again. Wow, look at that sharp peak of color balance now. I'm going to be pretty aggressive with that. Pretty aggressive with this. Now let's do our thing where we plate solve only, and then put Einstein's cross back in the crosshairs again. Supposedly where it's supposed to be anyway. I don't think the other guy is looking at the same part of the sky as we're looking at. Because look, we don't see, what we see is this, what would you call this astrosmear? It's like a little hermit crab, whatever. That's at 400%. So the first challenge is seeing the galaxy. Those almost look like hot pixels here. Look, I think I've got hot pixel removal on, but hot pixel sensitivity is on 5. Wonder if we put it on 3. And let's start that over. Dave says, I've never used Nina. SharpCap focus seems okay to me. Ray says, there is a focus routine in SharpCap, but it's really slow. Dave says, it is slow. Corin says, I use Nina for astrophotography. I just had something eat and some tea while watching. Oh, that's good, Corin. Ray says that he uses Nina for his imaging. All right, so we're at 400%. What that means is we're way past the scope's optical abilities, and we're into the, what you might call with a camera, the digital zoom. So this galaxy, PGC 69457, I like to figure out what is the magnitude of that. So let's go back here and close that, and let's say PGC 69457 magnitude. Cosmic Challenge, Einstein's Cross, Phil Harrington. Huh. Okay, so 69457 is a magnitude of 14.5. This is an astrobin picture. Let's go look at this. How do you make that bigger? Shift plus, Shift Control, there you go. I don't even see our little, look, here. Here's our little, what do we call it? A little creature. Where is the PGC 69457 in this picture? Oh, there. PGC 69457. But I don't see the galaxy. 8.2 meter telescope, 11-inch Onalaska, Texas. Now we're talking. That's what the galaxy should look like. Okay, so it's not beside our little this looks kind of like a question mark, doesn't it? Is that backwards? A backwards question mark. Where is the is this our little hermit crab feature? Let's go back to the live view. NGC 7360 and in IC 5241. See, look, there's the location it's supposed to be. And there's that little hermit crab feature. But I don't see the backward question mark anywhere. A seal and a crab, Wendy says. Corin says we need some imaging time from the James Webb. So Wendy says there was a seal and a crab. Where did you see that, Wendy? You're saying in his photo here there was a seal and a crab? Not seeing it, Wendy. Boy, that galaxy just... that sticks out in this picture. But look at the live picture. Not so much here. Of course, we're at 7 minutes, too. Boy, it's really dark out there now. And the clouds are gone. Wow, that's inky black. I love it. So it's supposed to be right there in front of that hermit crab, supposedly. So we'll zoom in some. So where's the galaxy? It should not be that hard to find this galaxy. I tell you what, let's go to Stellarium and let's do a search for PGC 69457. Boy, there's a lot of latency there, isn't there? Hooker's lens. .82. Look at that. It has Einstein's cross here. So I wonder if we don't have the right location of Einstein's cross. Because look, there's where Stellarium pinpoints the galaxy. Yeah. I bet we don't have the right location in... So the next thing we need to do is confirm what are the exact coordinates for Einstein's cross. And wouldn't they be on the web? We should be able to find this, right? Einstein's cross wiki. $22.40. Ah, yeah, ours are off. 22, so we're going to edit this. 2240, 30.3. We were way off. Plus 3, 21, 31. What these are, the right ascension and the declination coordinates on the celestial sphere. Okay, so now what we need to do is go back to our deep sky image annotation and remove the bad coordinates that we pasted in. How do we do that? Oh, it lets you edit them. Maybe. No, it doesn't. It doesn't let you delete them. That's sad. Well, let's see what happens when we overwrite. Let's remember, okay, so we're going to try this again here. Sharp cap DSA.
DSA completed.
And then we're going to go back here into the little editing box. And we're going to say paste custom. Oh, it made a new one. So now, let's remember we have one here. The one in front of the hermit crab is the wrong location. Instead, this is the better location. And sure enough, there's the galaxy. Right there. Okay, that's at 312%. Boy. What you hear is the sound of my voice being a little discouraged because we're not going to be able to So this is this line of stars we were looking for a while ago. Remember? 1, 2, 3, 4, and then the little mountain. And then down from there is this galaxy. So now the question is, so how does this work? Let's go back to the Astronomy magazine. (15.5 to 18.5). You have to have a 24-inch telescope. Several amateurs have succeeded in separating two components with a telescope as small as 18 inches. Yeah, that's not good, is it? So what you're going to do is just eventually try to make out a couple of those nodes behind it. So the quasar is 8 billion light years away, directly behind the galaxy. So we're going to find a diamond of 4 lights around the galaxy. And what makes this particularly hard is that's the galaxy right there. And we're already at 300%. We do not have the right telescope for this job, do we? RASA has a 1.5 degree by 1.25 by 2 1.25 by 2 1/3 degree, 2 1/6 degree. We need a very, very high focal length telescope for this job, don't we? On the other hand, we are using EAA. So quit your complaining, Doug, and let's just do the best we can. Now at that point, it's beginning to be really pixelated. -17 minutes of integration so far. Scene conditions are not great, Corin. There's that question mark. So it really is cool that we can see the galaxy, huh? But Okay, so if we turn down the background noise a little more, we do that by moving the black level to the right. What we're basically doing is saying, this is the new definition of black. And we're going to turn that background noise down a little. Now we're going to dial up more mids. Boy, focus is just critical, isn't it? And look, our focus is not perfect at 465% of our optical zoom. We're way into the digital world. Now let's go back out to the web. Now that we know what we're looking for, see how this galaxy really doesn't say very much. Do we really have to see an ad running down there? There's not very much of a spiral plane to this galaxy. Hubble site. What I'm doing now is just trying to get some realistic pictures of this. So we have something to compare with. Okay, so here's the galaxy. I'm going to enlarge this now by holding the Shift key down. Okay, so this guy used a plane wave CDK24 2 times Teleview Barlow. Not very much there, but there's possibly the two lobes in his view. So really a high focal length scope. Everybody will buy Kodiak Bear Bites on Sunday. That's the biggest part of the night, isn't it? The Kodiak Bear Bites. Why can't I get rid of this picture? There we go. Lots of people talking about it. very few actually able to capture it. ESO France. ESO's Very Large Telescope Array. I thought a while ago we had a guy in Cloudy Nights. Here we go. Oh, look, that's all he could see through his 18-inch. That's about what we're seeing, right? Look. So when he says got it, huh. Okay. So just to put things in perspective, that is at so things are still sharp. This is the bad one. That's the good one. So we've got the galaxy, but as to seeing those lobes, boy. Bummer, huh? That's 27 minutes. That's already a lot more than we normally do. And okay, here's what I'm going to do. See that little shade of a shadow right there? And that little shade of a shadow right there? I'm going to say that that's a very, very low quality image of the two lobes. Just to put things in perspective, there's the galaxy and there's the plane. So here's the sketch. See how you can see the orbital plane, the galactic plane, and then look at part B on top and part A below. See how those have a little more separation. So what we're doing here is Here's the plane, and that little shadow there, and that little shadow there, we're going to say those are the part A and part B lobes. Now, as to whether or not we would have discovered this and known what we were looking for, I don't know about that. But I think if you use your imagination, you might be able to pretend that you can barely make out a lobe there and a lobe there. And then you can tell people, oops, you're in that, sorry. Okay, see how the galactic plane is across this direction. And then look at this shadow of a lobe there and a shadow of a lobe there. Now, if you go along with that, shadow of a lobe there, shadow of a lobe there across the galactic plane. If you go along with that, then we're going to say that this has allowed us to see two parts of Einstein's cross. That's what we're going to say. What do you guys think? Effective advertising, Wendy says, for the Kodiak bites. Needs more power, Scotty. Yeah, look. Look. See the dot there and the dot there? That's at 30 minutes. A dot there and a dot there. See the dot up here and the dot there. Wow. And if you pretend really hard, you can imagine that there's a dot here. So I think what we're seeing is A and B, and if you pretend really hard, we're seeing C. What we're not seeing yet is D. Check it out. A and B and C, but D, I think that's so far just Doug's imagination. But I can see A and B. I mean, this is probably not the picture you would hang above your fireplace, is it? Wendy says, I'll go along with it, Doug. Ray says, that's cool, only a few more hours to go. Wow. The more I look at it, the more I'm starting to see D here, if I use my imagination. D is out here. Look at it. A, B, C, D. Woo! Corn says, okay. Wow. Now these bars down here at the bottom had to be just right, I grant you. A, B, C, but not hopeful about D. Okay, maybe. Just barely maybe at 33 minutes. Okay, when they said we would need a 24-inch scope, I have to admit I was a bit discouraged. But the more we looked, the more my imagination began to believe we were seeing parts A and B. Finally, I could even pretend to see part C. D is still a stretch for me. Larry says, you scared my dog with your woo. Tiffany says she's going with it. Dave says, scared me.
Observation logged.
You know, I've always heard of Einstein's Cross, but I've never been here before. So it's a nice place to visit. I'm not sure I'd want to live here, but there you go. Boy, you need a moonless night and 30 minutes. Wonder if we should take a picture of that. Is it worth photographing? It's wild, isn't it? You know, you kind of have to just love this in order to look at that. We are seeing that. You got to use your imagination a little bit. A, B, C, D is tough. Boy. Yeah, I think we should take a picture of it. Einstein's Cross 0804 36 minutes 111 frames. Okay. Well, it's 12:30, gang. If you guys need to go, it was hard to find, Wendy. You're right. If you guys need to go, I will totally understand it. We'll call it into it. I grabbed a 1-hour nap this afternoon because I saw that it was going to be clear later in the night and there's no moon. I think we're going to push ahead for just a while longer. It's 12:30. We actually started fair and square at 10, didn't we? So we've already been going 2.5 hours. Wow, time has flown by. So I'm going to go ahead and say good night if you have to go. But then I think I'm going to go ahead and push forward just a little while longer since I did that 1-hour nap. So good night if you got to go, if you're on the recording and you need to go. But I think I'm going to push forward. Let's see what else we got. Let's go to Terzan 7, whatever that is. Globular cluster. We've already stopped. So we're going to slew to the object. This is Terzan, sounds like Tarzan. Terzan 7. We lost our scope cam again, didn't we? We'll send you careening into the sky cam. It's funny, isn't it, how you can see the inside of the observatory, and that's the ladder hanging up there. If you turn your head to the right, you can see the ladder hanging on a hook. Let's see. I'm trying to get the scope cam back. We're going to have to find a better system for the scope cam because this thing is not working. Just drops. 3514. This is just not a good solution. This trying to mirror my silly phone screen. Just not a good solution. Now I'll go back to the scope cam. Still not working. Oh well, it's okay. All right. Terzan 7.
Selected.
Not much to it in Stellarium. Not marked in SharpCap. Thank you, Pete.
DSA completed.
Right there. It's supposed to be right in the center. So what exactly is it? Huh. This is object number 172. Terzan 7. As if the Palomar globular clusters, which were introduced in Chapter 6, weren't tough enough, the Terzan list of 11 globulars present an even more daunting test for the largest amateur telescopes. These clusters were discovered during an infrared investigation of the plane of the Milky Way by the French astronomer Terzan in 1968. All of Terzan's globulars lie near the plane of our galaxy and, as such, may be seriously impacted by obscuring dust clouds. Besides its unique location, Terzan 7 stands out as one of the youngest globular clusters ever discovered. Locating Terzan 7 takes a good view of the south. We're at 17 degrees. Begin your quest. Faint glow measuring about 1 arc minute across. Boy, it's just a little faint glow. We're at 115%. Let's back off to 100%. And let's dial up the background just a little bit. Now let's dial up the mids. It's at 5 minutes of integration. Tiffany says, may I just say thank you to all the folks here for the chat and friendship. She says, Terzan 7 sounds like a Star Trek location. You're right. You're on bear bite power. That's right, Tiffany. Wendy says, you're fun. Tiffany Ray says, it's always a pleasure. I'm not seeing this thing yet. What is this supposed to look like? Okay, so should be right here. Right there. Ah. Seven minutes. Tiffany says it's been a challenging week for me. Tiffany, we have some time here while we're trying to pull in Terzan 7. in case you want to tell us why it's been a challenging week. Um, see, minus 34, 39.5. Oh my goodness, Tiffany had to be evacuated from her home with a gas leak. Corin, I hope you can sleep. 5:44 a.m., at least get a couple of hours. Thanks for staying with us. A gas leak. Well, thank goodness it didn't like explode or something. Did you find the source and is it fixed? That's what we want to know. Good night, Corin. Wendy says, we're glad you're here. Aha. Is this it here? That's starting to look like a globular. Right here, I think. Yep, that's it. Not very photogenic for us, but it's there, right here. The smallest, faintest glob we've ever tried to see. Looks like at least 8 stars resolvable. A lot more in the glow.
Observation logged.
Boy, it is dim, isn't it? So the power company shut off the whole house. So you probably don't have a stove. You don't have a working stove. You can't even make scrambled eggs. And do you have hot water? go to IC1613. It's just at 12 degrees. 12 degrees above. I wonder if we can hit that. Let's try it. Electricity, no gas, no hot water. So you've got electricity, but no gas, no hot water. Well, that's sad, Tiffany. So sorry, but of course we're glad that you were not involved in a problem with the gas. That'd be horrible. I'm afraid we're down into the horizon here. Let's try this. Stellarium
Selected.
sync. Well, that should be visible. Oh, we're still moving. So we're looking now a little bit south of east, and that's the horizon. This is the building I'm in over here. That's just above the horizon at 12 degrees up. Not too high. Oh yeah, we've got stars. This is IC1613. Wendy says, no Kodiak pancakes. Bummer, Tiff. Camping out at your own house. Tiffany says, Wendy, that's a crime to be without pancakes on Sunday. You're right. I think, Tiffany, you probably picked up Wendy saying you won't be able to make Kodiak pancakes because your stove is off. So Tiffany says, I collapsed in the basement. God didn't want me to up there yet. Boy, Tiffany. So what'll be the next step? You've got to get some kind of plumber to come in and discover where this gas leak is, right? Wendy says, God has good plans. That's right, Wendy. There you go, irregular galaxy. Right here. Ray says he's going to keep you in his prayers. Tiffany says, yes, plumber pressure test, lines capped to replace, then another pressure test. Sounds hard and expensive. Wendy says, I'll be praying too, Tiff. Tiffany says, you all are really amazing. Why don't we just pray right now? Okay, here we go. Lord, as we wait for IC1613 to hopefully come into view here with more integration time, we just pause right now to thank you that Tiffany and her home and her Shih Tzu were not hurt through a gas explosion. And thanks that by turning off this gas, she was able to avert that. But now we pray that you'd help her to be able to first survive the annoyance of being inconvenienced by not having any hot water and no ability to cook. But we also pray that that would resolve quickly and that you'd keep her safe during all that, and that you'd provide for the funding for the plumber and the group to be able to find the leak and then test it well and restore everything back to full. And thank you that she's able to come tonight. It's pretty amazing that she was in light of everything else, and just ask that you'd really bless her. Thanks for this community and for the camaraderie we feel here, Lord. In Jesus' name, amen. Thanks, Tiff, for sharing that and letting us kind of into your home there. This sounds like a hassle, and so thanks. All right, well, IC1613 is supposed to be making its way here, but not seeing it yet. It looks like it will be perhaps right here. This looks like a hot pixel here. Huh. 6 minutes of integration, and we're at 14 degrees above the horizon. Ah, look at that. It's an entire bubble here, I think. See where that's starting to form up. So I think this region here is just a whole region of irregular galaxy. See that little cloudy looking guy there? IC1613.
Selected.
Oh, we've got artwork here. Yeah, look at the way this looks. It's just it's a cloudy mess. Look at that. So it should be between, see, these two stars kind of point into it, and those two stars point into it, and those two stars point into it. So 3 pointers, but it's really between that brighter star, and look at this little pattern down here, and this looks like a parabola that it's resting on. So here's the parabola. Those two stars point at it. Objects like this just take time. This is already 10 minutes, but... And notice if we set the background glow too high, then the whole night sky starts to glow. That it's like ghostly right here, see? It's a ghostly reddish kind of pattern that's kind of wafting in. Very irregular. See that? IC1613. This galaxy reminded us more of a cloud than a galaxy. I guess that's why they call it irregular. very faint. We were just starting to see it waft in after 13 minutes on a very dark night, dark moonless night.
Observation logged.
Tips as a test and a challenge for sure. Just almost looks like a equivalent to a hydrogen alpha region, doesn't it? But it's a galaxy instead of a cloud. All right. Let's go to something a little higher now, so we can get out of this low horizon deal. Let's go to IC 5164. This is supposed to be object 62. Oh, this is that dark nebula and emission nebula. We went to this Testing 1, 2, 3. How about this? Is this back? Yeah, that's exactly what happened, Tiff. The microphone ran out of gas. It is a little bit longer live stream tonight because I got that silly nap, so I'm stretching you guys to the max here, aren't I? And even, yeah, so that's recharging. Okay, sorry about that. Okay, so now I'm using the webcam. I doubt if it's as good a quality, but sounds like you can hear. Dave's got Saturn in view. Good. Thanks, Tiffany. All right, so we're looking for let's go look at Stellarium. Oh, wow, this looks like the Cocoon Nebula, doesn't it? I didn't even know it by that name. IC5146. Let's put Cocoon Nebula in our extra name here. Cocoon Nebula. Okay. And Barnard 168 is all part of the same feature. Okay, good. You're saying you can hear now. So this Barnard 168 is the dark nebula in front of the hydrogen alpha cloud, which is IC5146. So now let's go back and see. Boy, it's just, I wonder if that's the cluster. Yeah, there's the cluster, and that's probably powering up the it's actually probably powering the hydrogen alpha cloud. It's odd how pinpoint the color balance is. Such a sharp, see how it's such a sharp pinpoint. Nine minutes. Guess we're looking pretty high up, northeast. makes the black level so persnickety. I'm having to hold down the shift key, put it a little bit farther to the right than normal of the crest at the top of the peak here in the live stacking histogram. Look at all the blue cast to that. See if we back that up. Yeah, there. See that cluster here. 5163. So there's that cluster above it. And then another couple of brighter stars in it. There's the cluster above it, a couple of brighter stars in it. But you can't really see much of the cocoon yet, can we? After 11 minutes. Seems like this hot pixel removal threshold is set too low now. Let's put that up to 4 because we're seeing a lot more. Wait, if we're seeing more, remove satellite trails. Test, highlight trails. This version of SharpCap has a remove satellite trails option now. Trail detection sensitivity, minimum trail length, trail width. That's cool. Thank you, Robin Glover, the programmer for SharpCap. Hot pixel sensitivity. I don't know what that should be on. But we're seeing more hot pixels here, so let's change it and see what happens. Sure not seeing much of the cocoon yet, are you guys? Let's do this. Let's go. Now that we changed the number, it had a typo in it. It does say we've observed it before. So let's go to the Observations tab. Let's look and see what we said. We had just begun seeing this object in the faint darkness when each new frame became brighter and brighter with sunrise. Not our best view of the Cocoon Nebula. We saw 3 kinds of nebula: red, hydrogen alpha, grayish blue. Dennis saw faint blue, emission nebula, and dark nebula. Amazing these objects are right there waiting. Huh. Robin's a rock star for sure. No Cocoon yet. All right, Dave, good night. Appreciate you being here. We went a little longer tonight, but it's because I took that nap, and you guys didn't get to take one, so feel free to hit the sack whenever you want. You guys are faithful friends, but we understand totally. Dave says, nice show. You're very kind, Dave. Well, the other comments that I've made in the past, 21 May of 2021 and September of 2021, and then April of 2022, we've looked at this object before. You're right, Wendy, we don't see it yet. They don't tell how long it took us. Oh, Ray says you've been napping. That's the secret. Ray, do you have experience with the Cocoon Nebula? Have you ever, you have a RASA 11. Have you ever noticed how long it takes to bring it in? Let's back these mids off for a minute. Just get a sense of, first of all, the black level. Could go to right there maybe. Okay, now I'm just starting to see it come in. It says magnitude 999. That's crazy. Evidently I didn't have that configured correctly, so it's not showing the magnitude correctly. Ray says, yes, I can see it right away when I use your L enhanced filter. Okay. Definitely a problem for me tonight at 17 minutes. And no Cocoon. It's crazy, isn't it? I think I'm looking at the right part of the sky. Check these coordinates just to be sure. So we need to go find the IC5146 coordinates just to be sure. Now it's spooked me out because that other object had the wrong coordinates. See, IC5146. $21.53. Maybe this is the problem. Doesn't look like these are correct. 2153. .7. Wow, that's way off. How could this be? 47, 16, 01. How can that be? And they're wrong for the yeah. Okay, so I'm glad we didn't wait any longer. Let's go here. Boy, that's the problem when you've had to manually type in. Now let's slew to this again. Significant difference. Okay, there's the new location. I was in the wrong location. Redangle of $sign. It was a problem of the targeting software having the wrong coordinates, sadly. Not sure how that could have happened because I don't think I typed in all those coordinates manually when I made this. When I made this observation list, I don't think I typed in those coordinates manually, so I think I must have imported this from the Astro Planner observation list. Whoops. I had the wrong coordinates, Ray. That's why it wasn't coming in after 17 minutes. So is it really 1:30? Wow. So this will be our last target for sure. Oh my goodness, you're right, Ray. It comes right in. This is what it's supposed to look like. Okay, so let's color match this again just to make sure we're... Yeah, this is more like it. What a rich star field, right? Look at those. I mean, it's just almost solid stars. Now you can easily see, just like our previous observations had shown, you can easily see the IC5146 hydrogen alpha, and then you can see this trail of this Barnard 168 dark nebula. And then the dark nebula C is in front of the hydrogen emission, causing this part here to be blocked out. So that's crazy that after 80 seconds, you can see that. Boy, it sure is touchy on a night that's completely dark like this. I'm finding those peaks to be so touchy. I wonder if it has to do with some kind of setting. Anyway, that's just 2 minutes of integration, but you can see how this IC5146, the Cocoon Nebula, is an amazing target, huh? As we view this longer, it is beautiful. Wendy and Tiff, you're right. As we view this longer, we'll see more and more of this blue. Can you see some of the blue that's surrounding it? It's just starting to come in. But the blue would be what? Like oxygen, right? So you've got oxygen emission from this star cluster, and then you've got hydrogens being lit up from behind like a neon lamp. And then you've got the dark nebula that's covering up part of the hydrogen in these rivers of dark nebula. That's dark gas like carbon and other heavier elements of dark soot, basically. It's soot. And the soot is preventing us from seeing some of the cloud. Such picky. I'm holding the shift key down and it's still picky. There's a little bit of latency too, probably just because I'm overloading the laptop with stuff to do. Man, how can we count those stars? Is there software that lets us count those? Because there would be a lot of stars there.
Observation logged.
Really, these two objects should be associated.
Observations for two objects logged.
It's beautiful, isn't it? That's after 7 minutes. Ray did this for half an hour with his 8-inch, and he's got that on his AstroBin page. I tell you, that's pretty amazing that after 7 minutes, this RASA can pull that in with that much detail. So many. I bet there would there be hundreds of stars in that picture, right? Hundreds? So many little pinpoints. And each one of those stars, I guess it's conceivable, each one of those stars could have planets. Wow. It really does just scream that something or someone, I mean, obviously you know my belief. This just seems so unlikely to have happened by chance. So personally, I really do believe this was created. No matter how you slice it, that's just so much complexity. It just feels to me like it's so hard to imagine. It would take greater faith to think that that all happened by chance than it does to think there might as well have been some intelligent designer. All right, well, with that, we'll call it a night. Thank you guys for being here. We stayed longer. I think we started at 10, so 11, 12, 1. This was 3.5 hours. But we got off to a very slow start because of the cloud banks. So thanks for hanging with us so we could get some stuff done, get some work done. And what a great object to end on. So many of our objects lately have been so, we call them exotic, meaning they're so rare. But this Cocoon Nebula is fairly well known, but I don't know when it has struck me more. All that dark river of Barnard 168, and then the beautiful glow of the IC 5146 that is a Cocoon Nebula. It really is a good object to end on, and like I say, you can start to see now the blue emission nebula coming in around the outside. Thanks a lot for being part of this stream tonight, whether you're watching live or recorded. If you like this kind of content, be sure and hit the subscribe button so when we do these kinds of live streams, you'll be notified. You can click the thumbs up if you like. Only if you like this kind of content. It's up to you. Doesn't cost you anything. And if you click the bell, you'll be notified right away when we're doing this kind of content. You can also go to emeraldhillskies.com and sign up for the email list, and we usually try to email out as well. In case your YouTube notifications aren't working, you'll at least get the email. And Lord willing, we'll be here again tomorrow night, somewhere around 10 o'clock, I think. 10 o'clock, we'll say. And we'll go tomorrow night 10 to 12. So thanks again for being a part of this. We'll look forward to seeing you next time. Thanks for hanging with us. Thanks for all those who are live with us. Larry and Tiff and Wendy. Tiff says God did some amazing work. Ray says great time tonight, thank you. Wendy says maybe thousands of stars. Wendy says it would be a good party game to try to guess how many stars are there. That is good. Ray says take care, Tiffany, and we'll keep praying for you. So we'll look forward to hearing any updates, Tiffany. If you get a hold of a plumber, of course tomorrow's Sunday, it'll be harder. But thanks everybody, good night, and God bless.